All right, we are given this world population is being modeled by this following function, blah, 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 time in years since 2015. So when you're given something like this since 2015, that actually means t equals 0 is at 2015. So it says find the tangent line at 2040. Well, if you take 2040 minus 2015, I think you will get 25. And I want to find that prediction. That's what I want. What you want. So if I want to predict the population at time 25, which is the year 2040, what I do is I take what I know, my rate known, and my gap. If you look back on slide 14, I believe it was, I had you do this for a reason. Just give me a reason. And so these values you have, and the gap from 25 to 24 would just be 1. All right, so let's do it. So I have P of 25, and again, you probably can just go back and look at your slides, but now this is going to be 7.358, 1.013 raised to the 24th power. Okay, so that's P of 24. Now I need the derivative. So the derivative of this function, this piece right here, so I have 7.358, 1.013 to the t power. This piece right here is at a to the x. So this is why you will see me write the 7.358 is just out front. The derivative of a to the x is a to the x, which is that. Then times the derivative, the ln of the a, 1.013. So that is a shortcut formula, and then times the 1. All right, so if you don't remember that, look it up. The derivative of a to the x is a to the x times ln of a. Now from here, I'm just simply going to pick up a calculator, and I'm going to type in 7.358 parentheses 1.013 and raised to the 24th power, and that piece right there give me 10.03197571. Why not keep decimals? Right? Why do y'all get rid of the decimals? And now I can just simply take that. Oh, is anybody screaming, why'd you put a T there, Miss Sandy? That should be a 24, right? 24. All right, and so then from here, this is going to be basically that value, then times ln of 1.013, and I get this 0.129575258, all those decimals because this is in billions. So I simply just add, right? So I have those two values, I add that value plus that value, and I get this 10.1615597. Because if you think about it, this value is in billions of people, peeps. And if you just dump a bunch of these decimal places, you just dumped a bunch of people, right? And so this is important that you understand what you're doing. Yes, you have a function that you could just actually plug in 25, 8, 1.013 raised to the 25th power. Come back, wherever you are. So 7. I probably have that somewhere in my calculator that I can just go up and change that 24 to a 25. And this gives me 10.1623914. So, I mean, you can see that starting right here, these values are different, and you might say, well, that's not really too bad because 10.16, these are in billions, so that is, certainly a big difference. But this side over here is the prediction side. Turn my phone off because somebody's root me in. This is the prediction side, and this is the actual side. Because then, as you're going to see later, well, what if you want to find, say that? Well, now you have these values, 25 plus p prime of 25, and then you'll have this gap, of course, is bigger, and as we said, we don't really like, to do a gap that big, but, sometimes this is all you had for prediction, hence why predictions are not always spot on. So hopefully that helps, hopefully.